I thought I'd do another one of these just because I thought it'd be a good idea to show you guys what arctangent ones look like. So if you were to do this and you didn't have answers, you might think to do u substitution at first. But if you set the denominator equal to u, you'll see that du equals x dx, or has an x dx in it, and there's no x in the numerator, so there's most likely not going to be a u substitution like that. So we have our inverse trig functions in mind, and if you guys take a look at them, you'll notice that there isn't a square root on the denominator of what our result, or our integrand right here, and so we definitely are not going to be using inverse sine. We're going to be using tangent. But let's manipulate it a little bit so we can get our a squared and our x squared on the denominator. So first I'm going to write it out, and you'll notice that I take out the 1 over 2. That is a scalar, and by doing that, now the x squared has a positive 1 next to it, which makes it eligible to be so we can complete the square. So to complete the square, you're going to add a blank and take away a blank from the polynomial in the denominator. And to do that, you take the 2, divide it by 2, and then you square it. We get 1. So we add the 1, then we take away the 1. Now we can write this out with the completed square, the perfect square factored. And now you can clearly see that this is going to be your x squared, and this guy right here is going to be your a squared. So that means our x equals x minus 1 and our a equals 3. So we're going to write the 1/2. Don't forget about your scalar. You always want to keep rewriting it because you don't want to forget it. And we're going to do the integral of this, which we're going to use our formula for. So because x equals that, a equals that, we just have to plug it into what we know about integrating and getting the result of inverse tangent. And then we're going to have to distribute this 1/2 to these two guys. All right. Now, when we multiply the 1/2 to the tangent, inverse tangent, you're only multiplying it to the number that's multiplying the tangent inverse. You can't multiply it to the inside of tangent because it's inside the tangent. All right. And then, so we get this. We get 1 over 6 tangent inverse. And then when we multiply it to the constant, nothing changes. It just becomes a different constant. So we have our plus c. So that's your answer.